Good evening. This is Inyasura Singh speaking from Bharat, India. Let me first congratulate you, wish you happy 2021, though it's not going to be happy yet, we have to say happy 2021 from each and every aspect. It's time, COVID-19 time in 2020, whole year it was COVID time, and I expect that coming years also will have this problem continues and maybe for many more years. According to scientists, we have no information is available, but prediction is that it will continue. So today, last day of 2020, after a couple of hours, this shall become history. And 2021 means 2 and 1 digit shall start. So wish you all the best for that, and I hope that this professional work may continue, new ideas may come in, and we'll share that one. I hope those who have interest in watching, in viewing these videos and files shall enjoy and do enjoy. I don't know, facts you guys didn't get any feedback. Well, title of this video is yesterday I made one. It's continuation of that one. Mathematical formula demonstration, equations, geometric shapes, a combination of shapes A to Z 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is today, 31st December 2020. Various combinations and letters, of course, the sequence is already talked to you. And I have put possible URLs on text of this video. That is all, whatever last videos I relate for mathematical connections, it's there, all URLs. And of course, I would like to share some drawings in next video or other videos, because this is now I put an Excel share. If I change it, video stops and I can't continue. So for that, I'll share whatever drawings I produce to you, and this is Excel file because drawings are not clear in this yet. We have to be careful about this. Let me go to original home, and that's where is formula generation and validation, and that is by me. And dates are given, means on which days we worked on this, and like that you can see we move along and we see many functions, many formulas, trigonometrical functions, algebraical functions, and like that various shapes we have in there, various shapes. You can see the shapes, and of course, square, rectangle, triangle, all shapes are there. There's no need, I think I should mention all again and again. You know what I say, what I do. Of course, this is from very elementary to highest level of consideration, and very, very, you can say, very, very preliminary figures to very complicated original figures. That's what we are doing in this. And I don't want to repeat all, just showing you past work. Maybe there are so many people. These are all combinations of various positions, various figures, which is moving on many, many more. Just for refresher, I am showing you, I'm browsing whole file so that I can start in different way. And all these are moving, and then after combinations of these, I'll show you figures also once again, so that you may remember what I'm talking about. Letter A to Z, this is, A to Z in a square position, square shape, all are here. Then we have other one that is not square shape but real shape. Where a square is written, it's not real but convenience for use, and where it's different, and that's here, I say real, and this is V, many more. You can see here, all these letters are there for your reference. Maybe it's very boring, maybe, but sometimes science is boring and knowledge is boring, and letter 1, 2, 3 also there. 1, 2, 3 or 4, all those. And then you can say so let me show you certain designs here so that you can know better what I'm talking about, and various shapes. You can see different approach in this case, and this is here 3, 3, and here it is. Here it is, you can see. You can see this, all various designs. Identify what is this. You can identify what are these. And these are all previous ones. We have seen previous ones. All previous ones. Just to know what we did and what we have to do now. That's we have to see. You can see all these diagrams, and I just wanted to refresh your mind so that you get what to do now. We go back where we started in. So we'll go to A and B and C, all that. So, we go down like this, and let's say we go in, and let's say real shape we are talking. So we are here real shape, of course, X, Y, Z. We have done X, of course we have done X in this shape, so this is not real. And it is here now. We will start A. I did here yesterday. Just remind what we did. This A we did yesterday, and of course we did in a hurry. This A, this A here, letter A, real shape A. It's real shape A, and like this area, you can see these divisions of area: 1, 2, 3, 4, 5, 6, 7. We divided these all inclined areas, no, not real, not straight, not rectangular, and we calculated them per variable A and extrude the two variables, in fact. One variable here, that is for strip, and this is strip, stipple like this, a strip here, and then you can say, of course, area 1, 2, 1, 2, 3, 4, 5, 6, 7. We worked out all areas according to requirement of letter A. That requirement is here. You see that one? Maybe I just put again block. You can see here is A, and these dimensions. I used angle, whatever angle is there. 76 angle I took here, this angle 76, and then we worked out that angle I took 76, it can be different one also, but I didn't use angle here, so you can use something else as well and find out this. So letter A, with height and with some width, 5 is width and 8A is height. 8A is height and 5 is width, and then A is unit of this, whereas all dimensions have been converted to A. All I mentioned here particularly, but do not worry about that because these won't be used as it is, but will be used in terms of A. A, or you can say unit of this. So all these areas have been considered accordingly. You can see here, area 1, the trapezium base is there, so this is in terms of that. So many A's, A over 2 plus B, like this, all formula of area we have used. And similarly, we calculated cos 14 because of 76, and we worked out this all areas accordingly. The area 2, this all area calculation is this all calculation for area 2, this calculation for area 1, and these calculations are for area 3, 4, and this for 5, 6, 7, and 8, and sum up here, and we got this, and then we moved for parameter, external, internal, and we worked out parameter as well. Then of course 3D work here means we have 3D extrusion variable, and then volume of solid figure as well as surface area of solid figure, top and bottom and vertical surfaces. So that's what we have done. And now we look at B. If we look at B now, you can say D now. B is also similar one, but with different approach, and it is a real shape, you can say. You can see this B again. This is B here, here, here. This is ordinary. Here it is curved, semicircular curved, which you have to work out accordingly. Here there is nothing here in this. There is nothing here in this. Solid part is this, this and this. So these are areas and these are areas. So we have worked out in two ways. One, this is strip here, and then curved, semicircular curve with radius internal one 12.5, external one 22.5. R is 12.5 here, there inside, and 12.5 outside, external one. So we have here area 1, 2, 3, 4, 5, and 6. And with, of course, variable A. In terms of A is 8A and 6A and 5A here. We are going to adopt. So this is what we see, what we did here. What we did here in real shape, letter B, we consider area 1, area 2, 3, 4, 5, and 6. And area 1, is ordinary rectangle. Same way 2 is rectangle, and 3 is rectangle, and 4 are rectangle. Area 5, is semicircular. So mid-arc we use for purpose of area. And same way we did in 6, area 6, which is also semicircular. And after calculating this, working of these areas 1 to 6, is summed up here, this rectangular area, and summed up here semicircular area, and then summed up both for purpose of record only. So we got two areas here in this case. One is for solid and one is for curved or semicircular. Now these are parameters. There are two ways, one is parameter and one is circumference. Two divisions are here because we cannot mix up both due to so many reasons, because we are doing professional work here. So perimeter external we have taken, then we have taken direct measurements of each dimension, and we have taken internal one, and after that sum of both external and sum of internal, and then we have summed up both, and then we have gone to various parameters are here. We have considered various radiuses and all that, and we detailed it in various tables, various total circumference found, and then you say volume of this plane area, volume of this curved area, semicircular area, and then surface area of plane area and surface area of curved area using this value 10, which is AL. This is variable for depth, so you can say it is L, and you can see in every one it is depicted. So you can understand how is this done. Now, how we are going to see now, after B we explained yesterday, just refresh you. Now it is C, letter C, very easy one, not difficult one, but we have to do that, that's the important one. What we did now, C, first to see what is C. It's easy one, of course. You can see, you can just go up and see what is that. It is like this, like this. 5 and 8a, and here is square portion 1, and this 3, and this is 2, which is a semicircular radius internal, because one radius is 30, other radius is 40, this is 35 in between. 30 here, and radius 30 means this is over 50. So, this 40, so if you take here 40 this, so you can say here is 40, and internal this is 30 here, and then, so you can see this balance is 10 here. So we did like this, so it's very easy. You can value is A here, it's variable, and all can be converted into A, and we use that one. So we'll employ it. We'll take it to our calculations. Area C. Area C, real shape it is, means it's not square shape, it's circular or semicircular, you can say, it's like that. So we have to understand that in clear terms. Let's say real shape now. It's a strip width, this strip. You know what is a strip, again I tell you what is a strip. Actually this width is a strip, this is a strip like this. So this is a strip, a constant everywhere. Alright, then you can say area 1, that is square, and this A into A. Area 2, that is arc or semicircular. So it says that pi r, and r is radius. Because this semicircular, so we are saying pi r, if it's full circle is a 2 pi r. And A is strip width. So r in this case we are taking, r is 3.5, which is average of 2. You can say 4 and 2. So it is 4 and not 2, 4, you can say 4 and 3, 7, half is 3.5. So half of both, it is 3.5 r, 3.5 a is value of r. So we can say here pi r 3.5, b simulated, which is here. So, and then further b simulated, because this value of a, this r is this is r. 3.5, this is r, and this is strip width, and this is pi, of course. So we got here what we say, we got this value here. Area 2, one is area of A into A, this is area 2, and area 3, what it says, A into A again, and I think it's same as, B88 in this. So these two areas are same, 1 and 3, because there are only 3 areas, and we can say curved areas is different and squares are different. So this is curved area same as this one, and total square area this plus this, so this is this one. You can see here formula, all formula, nothing without formula. So we have worked out here area now. Perimeter of this, now perimeter is not alone, it is with circumference. So we have to be careful. So there is upper, you can say, and lower parameters. So I have to take, that's A plus A, let's say how A plus A, upper and lower. This is the upper portion, this is lower portion, A and A, and A, and this part is not perimeter, that is circumference. So we have here 3A. In this case, both cases were upper and lower, A plus A plus A. This is A plus A plus A, and this is A plus A plus A, and sum of both rectangles is here. Then circumference curved external is pi r. It is pi r, because it is external internal, so we can say this external is pi r, where r is 4a, and this is 4a here, you can say pi 4 this, and circumference curved internal is 3a, you can say pi 3a. R is 3a, there R was 4a, R was 4a, that's different. So total circumference, you get sum of this and this, we get, then you see 3-dimensional go there, and see, then you can see volume here for plane area, and that is a G, value of G here for this one here, you can see this is G, so we can say Other one is, this is G, and the one is, and you can say that this G here, and curved one is F. So we talk about this here. This area is G, and this is P, of course, here, and this is F and P. And we get then plane rectangle surface area is 2 end area, which is here. G is 2 end area G, and then L is L. L is, perimeter. L, let us see what is that. L is perimeter, no. L is perimeter. So it is perimeter here. We are taking down there. So it is like that. It's like that. What I say there, that this is perimeter, is that L, and then here is P, and of course in circumference way 2F, of course F is there, and that is for circumference. So and P is there, and this is P, and O. O is here, that's total circumference. So actually I should take O first and P 70 later on. So I will take O and P, we can do O and P, no problem at all. Let us say O, and we say this is P because cell is same, P, and that's all. You can say same thing. So it is your O and P because O is circumference, then D is later on. Well, it doesn't make much difference, but we can say. So we resolve C. Now we go to D. D, we have to see D, how D works, First of all, we have to see its geometry. Its geometry is also important. We have to see that one, geometry of this. And that's here, geometry, You can see geometry first, that's important case. I'm not running fast because they're very complicated figures these are. This 8A and this 6A, and this is a strip here up to here, and then it's curved one, and then vertical, or you can say rectangular in this portion, and then curved one here. So it is like that. Area 1, area 2, area 3, these are curved areas. Area 4, 5, and 6. 5 is also curved areas. So 4 and 6 are quarter circular area, not semicircular, quarter circular. So we have to be very careful about this. So this is the measurement of angle, which is 25 and 20 and 15. These are here measurements of this. So we have to just think of this, how to handle this. That's the important point here. So D has how many areas? D has area 1, which is rectangular, area 2, which is rectangular, area 3 is rectangular, and curved area 4, and curved area 5. Curved area 6, curved area 4, area rectangular 5, curved area 6. So 2, 4 and 6 are curved areas, and then we have the total area of curve and total area of plane rectangular. That's what we have to take into our consideration. This is not very complicated one, a little understandable. I think you got my point, right? You got my point, and it isn't difficult if you go step by step. But with patience is a must here, where we deal with cells and there are chances of any kind of, error. So we must be clear about that. You can see, just have 1 minute, please. You can see these areas, how these are working. Can put on light, please. So these areas you must have seen these areas. You must have seen the area 1, area 2, area 3, area 4, area 5, area 6, as I said, rectangular, 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 curved, rectangular, curved, total here. Curved total here is 4 and 6, 4 and 6, and this is rectangular is 1, 2, 3, 4, 1, 2, 3, 5. Rectangular 1, we can say 3.5 into A, that's here, 3.5 into A, and area 2, and that is 6 into A here, and then area 3, 3.5 into A, then curved 4, area 4, that is pi r A, r is equal to 2A, you can see that one, pi r, you can say here 1 over 4, because it is 1/4 of a circle, quadrant you can say, 1 over 4, pi 2b 794 and b 800. Hold on, maybe some, you can say it is 794. Let me see. This is 1/4, 2 pi r. R should be 794 into again 794. I think there's an error here. You should correct that one. And this is 794. So let us see this one. Sometimes some errors do happen, so we have to be very careful. Again, see 1/4 of 2 pi r. 2 pi r is full area, full arc, you can say, arc of circle or circumference is 2 pi r. This is 2 pi, so 1/4 of 2 pi, that is pi, this is 2 into this one is 2 pi r. So this pi d actually it is, so we can say this is circumference and width, or you can say A is B 794. So 1/4 of this formula applies here, and then you can say area 5 is 8A minus, there is a vertical one, in between curves, two curves. One is top curve and one is bottom curve, in between this area. So 8A minus 2 into 3A, 8A minus 2 number top and bottom into 3A. So we get rectangular area by multiplying A here. So that's value here 8 B794 and minus 2 into 3 B794 B794. So we get value A. This value which is area 6, which is the same as F here, same as area 4. So it's in here same as area 4, cover area 6 square meters. This, though it is area 4. You can see diagram here. Area 4 and 6 are same. So area 4 and area 6, here 4 and 6 are same. So we can just write there also for reference that this area 4 and 6, so area 6 you can say is equal to area 4. So it doesn't matter. It's okay just for reference, because I linked that one with this area. The formula is there for calculation purpose, but I linked that one, so it doesn't matter, because if you want to use formula, you can use formula. It's the same formula as this one. Then total area curved one and total area rectangular one. Curved one is here, which is area 4 and area 6, and rectangular are 1, 2, 3, 5. 1, 2, 3, 5 is here. Curved one is here 4 and 6. So this is 4 and 6. And जाओ किचन में है, किचन में उधर जाओ, यहाँ नहीं है वो, खाना खा रही है, जाओ. And this is now area 4 and 6 here. Then you can say it is 1, 2, 3, 5, 1, 2, 3, 5, 1, 2, 3, 5. This is here, and that is 1500 because of this C1, C, D, then E, and later on G. You summed up all same row and you got this area, that is rectangular area. So we have two areas, one is curved area and one is rectangular area. curved area and rectangular area. We have these two areas. Then total area, square meter, plane, rectangular plus curve. That's total area for reference only. It's not necessary that we should do. We added this just for reference, but we cannot use them in totality. Then we have to see parameter. Parameter we have to work out. And if you see parameter, it's 3.5. You can see go and so see figure also if you wish to. And I mean, it has to work here this way, external, and that way, internal. So we have to see how we have to take parameter as well as circumference both. So we say 3 point, externally we are saying 3.5a plus 8a, 3 point is horizontal, plus 8 is vertical in this figure. This is not vertical otherwise, but a planar figure. I'm saying x-axis and y-axis. This is an x-axis, 3.5a, and this is y-axis, 8a, and then 3.5a, and then 8a. Then minus 2.5 into a, and this external, and 2.5 into a. That's why it's 2 minus 1.5a into minus 2.5a, and you can see the external rectangular it is. So it is external rectangular. I'm saying this is like this, and then maybe you can see here we have taken this, then we have taken this. What we have done, see that one. It's done like that. 3.5a plus 8a plus 3.5a plus 8a minus 2.5a minus 2.5a, and internal is 2.5a plus 6a plus 2.25a, 2.5a plus 6a minus 1.5a minus 1.5. This formula adjustments because of that figure. So we have here you can say this figure D here, which tells so much about this. You can say, because we use this dimension, so we deducted that one. Use the 8a here and deducted this portion, and then deducted this portion, and worked out this dimension. That's why it's there like that. Then we have worked out internal and external parameter or rectangular plan. Now rectangular sum is there for this external internal. Then we go to circumference. Circumference is curved figure, and pi r, that is external, you can say. Curved external is this 1/4 of pi r, though it's pi. Just leave it, because here is formula of external. Let me see what why is it like this for the reason. There's no reason for that. Just forget it. It is 1/4 pi r. It is means 1/4 pi r. It should be, though it is 1/4 pi r shown here. So it is 1/4 2 pi r, and 1/4 2 pi r, and this is here also 2 into 2, and 2 pi r is written, and r 2r is r is 2.5a. That's also written here. R is 2.5a, and so 1/4 2 pi r into 2a, actually 2a. 1/4 2 pi r means 1/4 of a circle, and that is into a. That is into a. Actually, it should be a. I say it should be a. This circumference curve, it is circumference 2. It is top and bottom. I can say so. It is like that. 1/4 2 pi r into 2, and r is equal to 1.5a. I just put comma here so that this will confuse them. External and internal is this one. You can say this is that one. This external circumference, 1.4 to this, and this is surface curve external. This internal, 2 pi r into 1/4 2 pi r, and r is 2.5a here. That is and value. So we can say here. Just a minute, please. Yes. So it's that 1/4 2 pi r into 2 and r is equal to, we can say r, let the comma here, r is equal to 2.5a. So we got here same value of 2.5 this one, and 2 multiplied by 2, and here it is 2.5 different. So both the methods are different. As 2 point, this is 2, is also 2 internal is 2 by r, 2 by r, and r is 2.5 here and r is 1.5 here. That's only difference. R is 2.5 here and r is 1.5 here. But cells is same means 7794 here. So we got two values, total circumference is this plus this, sum is Q and R, and we got this. Now we have to know this perimeter, circumference, and areas with us. So what is it actually 3D? Here too we have this extrusion and volume in cubic meter here. That's a planar figure, volume in cubic meter, curved portion, then rectangular surface area here, and rectangular curved area here. Curved area here. So this is whatever value here. Plane is this, go to area and see which cell is that. It should be J if it's right, or J should be there, and that's here, that's right. Rectangular and and curved is I. So we can say here this is J here, and this is J, and T is here, and this is curved. So this is I and T here, T, and this is T here again, T here again, and here front external surface area, because two end areas, and J, O, and T, J, O, is O, rectangular parameter, and then depth as well, and this is your other one, curved one, I, and T is S. S is here, that is total circumference. So we got this value. So we can say D is now resolved. This is little, we have to understand how we work. Curve is very important. Now we go to G, which is, G is here, though it's not very, very clear, but it is clear in a way. You can say, just see how it is. This is G here, going like this, Here is rectangular portion here, and this rectangular area here is a curved one. This rectangle here, then curved one here. So you say here, you can see various areas defined in this. When you see my drawing, it is clear to you. The area is 5 here, 4 here, 3 here, 2 here, 1 here. 1, 2, 3, 4, and 5. This area are here, and we have some curves are there, so we just move and study G here. G, that is real shape. I'm talking, it's not square shape. It's real shape. It's wonderful if you do with real shape, because that's what we use in life. But for some other reasons, we can use square shape as well to make it easy for some reactivity or some field. You can say you can do that. So it's now we're talking about this. You can say letter G, and it has area 1. Area 1, that's rectangular, and this is curved area 2. Then you can say curved area means it is 1/4 of semicircle. And then area 3, which is you can say area 3, that is 8a minus this into this. Area 3, let's use that, and then you can say this is this is J. 1, 2, 3. So 2, 3, and 4 like this. So 3 is also rectangular. 8a minus 2.5a minus 2.5a into a, and then curved portion again. So like this, it is curved portion. So a curved area A, you can say the same as area 2. You can say the same as area 2 like this. Curved here. This is not actually curved portion is different here. So you can say because this is semicircular, it is quadricircular. So we may say here that this is half of that, because it's here, so 1/4, it's half here. That's the only difference here. It's half. And area 5 is, it's not curved, but this area 5 is not curved one. There are two areas in that, so we'll go one by one and see how we work on that. How we work on that? Area 1, 2.5 A into A, and this is 1/4 of 2 pi, R is 2A, B 800 and B 800 is R1, and then we say area 3, it's rectangular 8, this minus 2.5 minus 2.5 into this, we get axial dimension by deducting from 8A, 2 times 2.5A, and we got this value. And curved area half into base, this is a semicircular one, this is half into 2 pi R, R is 2A, and we got this half into 2 pi R, this is 2A, and this again A, and we get area 5, that is square A into a half into A into A, and one is 2A into A. There was one whole square along with half square, and we can say this is dimension here, half of this and this, and 2 into this one, 800. Then we can say curved area here, rectangular area, 2 divisions are here, this is curved area. There's a D and F, and this is D curved one, and F is curved one, so we have summed up here as 2 and 4, and 1 plus 3 plus 5 is here, 1 plus 3 plus 5, which is here, C, E, and G. So we got this. So we got area coverage. Now total area per planar rectangle is just summed up here for reference only. This is sum of HI. That is, but working out differently. Now we have to find parameter of rectangular area, and this parameter, the circumference. So we say parameter in rectangular area. Parameter rectangular area. You say, let's go to see figure. It is, if you move on figure, you will find rectangularly, it is 2.5A plus A plus 2.5A plus 8A minus 2.5A minus 2.5A plus 8A minus 2.5A minus 2.5A plus 1.5A plus 2A plus 1A plus 1A plus half A. We have clubbed both internal and external here. You can see 1, 2, we can say 2.5A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 measurements here. We have taken 14 measurements, and it should be same on drawing. If you check, you will find them actually. That's where it is needed. You can say you will find that, and it shall be. You say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. You got it, So it's all like that, means this is in one direction, no interaction. So we can say this is total rectangular, and these are curved here, you see 1.1/4, that is curved, means if you take first one, 1/4 of a circle, 1/4 2 pi R is 2.5A. Other one is plus, add to this 1.4 2 pi R is 1.5A internal X. At one and other one, you can see both sides, and then half the semicircle pi 2 pi R and times 1.5 again starts, it says same one. And you can see this is real, you can see real dimension. That's here, and that's what it is, So this is all that. So we can go through calculations and say, let's see, it's 2.5, the other one is 1, then 2.5, then 8, and then 2.5, then 2.5, then 8, then 2.5, then 2.5 again, 1.5, and then you can say 2, then 1, and then 1, and then half, and that's what it is. So you say this is answer. And of course, if you take for circumference, circumference, you can calculate Because of curved portion, find 1/4, that is first one, that's 1/4 of a circle. 1/4 2 pi r is 2.5a, and 1/4 other one is 2 pi r is 1.5a, both inside and outside, and 1/4 2 pi same to one half of this because of circle. R is 2.5a, and so we got this value 1/4 2 pi this value, 1/4 2 pi other value, 1/2 2 pi this value, and other value. We got this answer. Now this is extrusion, and we can say if you go to area, you'll find where the area is. The total rectangular area is I, so this is I, and this M, this is M, and you can say that is what is about. That's what is about. That's what I say here. Then we can say cut portion is that one. Total area. I can say total area. Curved portion here. This is H, and this is H, and M. This is okay. Then we can say plane rectangular surface area. I can say two end areas. That's our square one. Two end areas, and that's I, and this I is two end areas plus parameter into D, and parameter is this one. This is K, so we can say K into M. And here we can say same thing, 2 into end areas H in area. H is area of curve, and circumference into D, and circumference is here, that is L into D, and that is M800. So here in this case, so we got this, and we can say curved surface area. So area surface D, curved surface area is 2 and areas plus circumference this beta. Well, this is what was told by like this. All right, we got this value of G done. I think we got it. G is the. I will move out to J. I'm taking case of curved portion, so or actual portion. So I have taken A, which is not curved but a spatial one, inclined one. We have taken B, which is curved one as well. Then we have taken C, which is curved one. We have taken D, which is also curved one somewhere, and then we did not take E, did not take F, G I have taken, we have curved one, H we have not taken, I we have not taken, J we have taken, J is also curved one, J, K we have already taken in other calculations, so K, L, we won't take, M we will take, M is spatial one, and N is spatial one. So let's talk of J now. J what says, J, you can say, let's blow it up a little and see how it works. You can say here 5 and 8A and 1 area and 2 area, and then semicircle and other area. That was design of J. You can take this design, or you can design your way. Same thing doesn't matter. So it is one semicircle involved in this, in addition to 3 areas. So area 1, area 2, 3 is semicircle, 4 is 2 coverage, and it is strip A. So we just move further on this. Now let's see what it says. You can see your way. Of course, this is, you can say, now already 48 minutes over, and I do not disturb. Maybe I enjoy your New Year day, Eve. Your New Year Eve, I may shortcut. I may take shortcut, but I just wanted to give something on Eve, and if it's not complete today, it may be continued tomorrow or some other day. So it's J now. We can say step with this, and the area 1, and that is, sometimes you feel tired. So I am not feeling tired. However, it's a letter J. You have to see this one. It's 6:48. So I can take up to 8. So I can do something. In fact, let us see if something is done, because I will just take some water, and that's all for my medicines. Area 1, that is rectangular, it's just 5A into A, and area 2 is rectangular, it's a 4.5A into A. Area 3 is semicircular, and that is That is, you can say, though I've taken in this case, area directly, so no problem at all. We can understand that because we have to take every measure. Sometimes I take center line that's between two curves and then width, use width for multiplication. But here I say I'm taking directly difference of two areas. So pi r square root 2 I'm taking now rather same circle. Pi r square 2 formula is there for half same circle area. And two areas as you use 2 into 5, you just use x on 2.5 and then 1.5 both have used. In this means this area minus that area, you can say. Got my point? Pi r square root to one area, pi r square to other area, one area, pi r square means that is 2.5. So pi 2.5 square, you can say, or 2 minus pi, of course, 1.5 a square 2 is a difference of this in this case. So there's a little difference, but then it's there pi r square is 2.5806 square, or 2 minus pi r square is different one on the pi square or 2. So we have used this one here in spatial case and as a spatial understanding. So this we got area 628, same thing as we got in other case by other way. So there's no confusion in this. Area 4 is rectangular one, that's 1 plus 2 plus 3. Yes, area 4, sorry, rectangular one, that's a into half a plus 2a into a. According to geometry available on that, we'll find this one. And that is not bad one, you can say. It's a practical one. So each total rectangular areas, and then you can see total rectangular square, which is 1 plus 2 plus 4. And that is rectangular area, 1 plus 2 plus 4, 1 that is here, and 4 is here. So this is, you can say, other one. And this is area 3, that's here, that's semicircular 1. So rectangle plus semicircle is this. And let's go by, first of all, let's say 5a into a. 5a into a, you can see 5a. 5a into a, and you can say 4.5a into a, and then it is pi r square. You can see the same figure here, and you can see pi r square, so to minus pi square 2, and then we can say half into, you see 1 over 2a there, and this is a half. A into first is a, and a half into then 2a plus a, the sum of this. And then we say total rectangular per square. I'm sorry, total rectangular area is 1, 2, and 3. And that's there it says, and total area, rectangular, semi-rectangular, because our case is that we have to, what I say, here area 1 plus 2 below is 3 area. Now we have gone this way, then you can say this is area 3, same as E, is area 3 here, and the sum of those areas. Now you come to parameter here, parameter part, and then we have circumference part, both are different. This is our parameter part. Parameter part says something, it says something. It says something here, 5a plus a. You can see that one here. And the side is 5a plus a. It's 5a plus a plus 4a plus 4.5a plus here. You can say 5a plus 1.5a. You can say 5a plus 1.5a. Maybe this way go 5a and a, 4a and 4.5a, then 5.5a, that is a, then 1.5a, then a, and you can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's okay, means it's that one. So we have to move and say here, 5a, 4a, then We have to see circumference as well and how it is. You can move this and see 5A and A, then 4A. You can see, measure this as 4A, how is 4A, then 4.5A, then 5.5A. And the circle is 2 pi r 2.5A, and this is here 2.5A curve here, and then you can say this is here. This says, this pi 2.5, this was pi 2.5, this one and this one here, 2, 1, and you can say this is curve. I think, let me see how this J works, if I can open this file. There's no J here on this, just no, you check it once again, please. If something wrong, we have to check. It's no shame on us, there's no shame at all. But where is J? Let me see, trying log J. B, you don't find J here, let me see, where is this? S to J, and let us see, where is J, this is J. There's different J here, it's not that J, I don't find J in this. And then there's geometry, and this is M here, so this is 1, 2, 3, 4. There's no J, let me see where it's, I open another file, make sure where it is. And let us see, open, and we say, let us see, A2R, let me open this file, I think. Let me open this file, but yeah, I think no, this is not the file. It's not that file as well. Yeah. Let me see, this is that one, no. Let's see this one, Let's see, is this one? No, let's see here. Yeah, here's J in this case. This is J here. So it is here, you can see. You may not see, but I'm seeing. This is here in 8A minus 3 of 5A. And it is, A into 3, let's say area here. Area of J, and it is 5A. Okay, 5A, let us see 5A. Let me see, it's 5A. It's 5A, then A, then 4A. This is 4A, all right, it's 4A. And then 4.5A. This is 4.5A, let us be sure. DI is how much? Let us see how long. Let me see. DI is 4.5. You may not see that, I'm just checking it. Just hold on, 3.5A. Yes, it's 4.5. Okay, it's okay, fine. It's 4.5A. And then we can say here, 4.5A, 4.5A, then 5.5A. 5.5A, I think, where it's come from, let's point here, 5.5A, and then it is 1.5A, 1.5A, okay, 1.5A, 1.5A, who's 5.5A, maybe this one is that, 5.5A, DI is this, I take a different way, DI is 5.5, this is 5.5, long DI is 5.5, DI, nice and working, DI, this is here, this is here, this is 5.5, okay, this is 5.5, so I've taken this one first, so actually there is 5.5 as well, so 5A, A, 4A, 4.5A and 5.5A are there. The 5.5A on the other side actually, external one, I made the 5, again I say 5A, oh come on, 5A, 5A, oh come on, 5A, 5A, A, 4A, and then 5.5A, that's right. And then it is 1.5A on other side, 1.5A, A, 1.5A, 2A, 1.5A, 2A, and then A, 2A and then A, and then again A, and then 0.5A, and 0.5A, that's okay, 1 over 2A, that is point, I say, see, one is, we can say 1.5A, right, that's okay, and that's not area for horizontal on that, and then this is this is 2a again, 2a 1.5 and 2a 1.5 and 2a, that's okay, 1.5 and 2a, and then a again 0.5a, again a and 0.5a, sorry, a 2 times a and 0.5a 1 over 2a, and then that's it. So it's okay. I'll explain to you on geometry now. Here, we have taken this complete first. This is 5a, this is a, this is 4.4a, this is 4.5a, and this is 5a, 5.5a. And then this is here, this one, you can say 1.5, this is 2, this is 1, and this is 1, and this is 0.5. So it's okay, there's no error. I thought there's an error. It's okay, fine. You have to be clear, but it's necessary. You have to be clear about this, no confusion, please. If there's a little mistake, means whenever you do other dimension of that, you'll find the mistakes everywhere. It's kind of, you can say, application. That's why I call it application. Once you enter value and finalize this, then you can't help it. That's why I'm demonstrating it, and simultaneously I'm trying to help if there's some errors. Correct. So 5a, 5a, a, 4a, 4.5a, 5a, 5.5a, 1.5a, 2a, and then a, and half. So it's okay. There's no error in this as well. So we can move like this, It's okay, and we can say. And then we can come to cursor, semicircular, and that is it. Semicircular is also important, semicircular. Pi r, right? Pi r, let us say pi r, and r is 2.5a, r is 25a, and r is 25, 2.5, pi r. Another r is pi r plus, this is here, you can say pi r, another pi r. Let it be clear, little clear, so that you should not be confused. Sometimes I miss also during composition. So this is, this is, you can say pi r, r is 2.5a, 2.5a, and this is pi r is 1.5a, and this decimal here. So that's okay. So we can say here pi r 2.5a, this pi is 2.5a. So we got some of this. And then extrusion stance, so now we calculate this. One is volume for plane area, volume for curved area, and the surface area for plane area, the surface area for curved area. So let's see, G is there, you can say, is there G valid for this? Yes, G is valid for this, there's no doubt, it's the total area. So G into L is here, and this area is a fine. And you take this curved area here, curved area is here, that is bias curved area. We can say curved area is, this is circumference. I'm talking of area, so curved area is, that is curved area, circular area, and that is H, and we can say H, yes, it's H and L, so it's okay. And then we can say two end areas means 2G here and GL, B here and GL. J, that's parameter into L, that's okay. And then so in this case also, H is there to H plus K is there circumference, and L is there distance. So this is okay. J is done, and now we'll say M. M is a little complicated. Meanwhile, you see dimensions of M first of all. That's very important. Let me just take some water, heat it up before I come. Hold on pause for a minute, and you see how this was composed. You can see yourself first. Sorry, Andy, and I just put on switch off my water heater and let it take half a minute or 2 minutes, and I'll go back again to take it because I have to take my medicine. So excuse me, don't mind please. It happens because I'm very sick. So you have to give me grace for that, right? If you don't mind. But meanwhile, the ground is open to you, AM is open to you, and you know how it is constructed, that's important first, because everybody has different approach for construction. I have taken them like this, but you are free to take a different way, which I think this is what we do. You can take middle apex down, which is area 3, no problem, but this is what I did. I'm an N hand, because it can be different in many shapes. If you think I'll make a different shape as well, but this is what I think is right, giving a comfortable area measurement. In this case, you can see here, this is 9A, this is 8A here. This is step A, goes like this. And you know, here I'm not considering the angle because we have only trapezium in these cases, you know. Area 1, area 2, area 3, area 1, trapezium, area 2 is trapezium, area 3 is square 1, area 4 is trapezium, area 5 is trapezium. And these dimensions are here, actual dimensions which shall be converted to A value. These dimensions shall be converted to A value. All these dimensions here, these are trapezium dimensions here, and this is of course A into A, 3, area 3, and this 4 and 5, and that's all. This A here strip width A. So we have 1, 2, 3, 4, 5 areas. One area is trapezium, 2 areas is trapezium, 3 areas is square, 4 areas is trapezium, 5 areas. So this is what I think you remember right now. So I change it and go back to you know, our calculation area. That is real shape M. Real shape M. Real shape M. That's the important one. It is strip width than area 1 trapezium, area 2 trapezium, area 3 square, area 4 trapezium, area 5 square, and then you can say sum of this. So area 1 is 7A plus 8A over 2 into A. That is 1, you know. This is 1 here. 7A plus 8A over 2A. And this area 2 trapezium, that's 4.364 A plus 5.36A or 2 into A. And area 3 A into A, so no problem. We have for another trapezium, and that is you know, under trapezium, that is 4.36 A plus 5.36 is same as area 2, area 4 is. You can say, I just written here, but you can say is equal to area 4 is no problem, equal to area 4, you can say area, sorry, 2, not 4, area 2, you may say, this doesn't matter, you know, it's okay, fine, it works. So then area 5 is another trapezium which is also equal to area 1. So area 5 is equal to area 1, we can say area 1, this is equal to area 1. Area 1 we can say here, area 1, it's okay, fine. And we can say it's like that. So then let us go and see these calculations one by one. I think to understand what I say, it's easy, not difficult. We have to just convert these areas into formula, and that is very important one. If you are successful in doing that, we have one application with us, you can say. That application is permanent regular. So in this case also, we have many areas here, and that is beauty of such formulations, that you don't depend on calculating every time, just like calculator does. No need of that. You can do whatever you want to do by that formula. So it is area 1 trapezium. You can see cells. A cell is cursor is in cell, and you can see how it is working. So this cell is saying 7 into BB12, 812, sorry, B812 plus 8 into B812, which is value here 7A into this 7A, and 8A divided by 2, and B812, which is A. So you get area 1. Same way area 2, 4.364 here into this cell plus 5.364 here in this cell divided by 2 into B812. You get second one. And third one is A by A, so it's okay. And fourth one is saying area 4, which I say B812. This means here area 2. So you just put in link in, and area 5 is area 1. We link in C812. And then total rectangular area is 1, 2, 3, 4, 5. Is some C to H. I'm sorry, G. We got this value. Now we have to see parameter here. This is also very important point, parameter. Let's see that one. How? Okay, no problem. Let us see. Now, it's very interesting actually, because we are dealing in real shapes, not imaginary shapes, or not useful shapes. Perfectly, this may not be used, but these are real shapes, These may not be used. Okay. Hold on, just going to take my tablet, please. Excuse me. It's night time. I take my tablet here and. Okay, I've taken my tablet. Thank you very much. Now, I say parameter. Yeah, see parameter, how it works in 8A. We say this is 8A. A. 7A. Then 4.95A is that one. And then repeat is that one. Means repeat all. We are repeating this one up to here. Means here this A we repeat, and 8A plus A plus 7A plus 4A. Repeat. Then 1.41 we repeated this one, right? We repeated this up to here. Then we can say then 1.41 is there, 1.41A, 5.36 here, 5.6 again, and 1.41A, right? Let's see, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's fine. So let's just see. Go to silence. You're saying 8 here. You see. So 8 here, 8 here, you can see 8A, then 1, 8A, then A, then 7, A, and then 4.95, and then repeat means to say, you can say 4.95, you can say repeat that, 4.95, and then 7, and then 8, and then 1, 8, and 1 and 8, and then 1.414, 1.414, 5.364, 5.364, and 1.4. So it's okay. Now we got this answer rightly. You see this answer is right, no problem. The extrusion of the criticism, because there's no curve in this, we are taking dark parameter, no circumference application here. There is no circumferential application here, so direct extrusion and planar area. And this we consider as, this area is here. This is rectangular area. This is H and J. J is that one. So it's okay. And to end the area, so and the H is there, I is here. So that's also okay. So M is resolved. M is resolved, okay? Now M resolved. Now go to N. And also we have to see first figure how it works. That's also important, How it works, that's also important. You can see this first here, how it works. Sometimes means 1 hour has crossed. No problem, it's okay. So we say that we have here arm like this. You can say this area and this line and this line, or this strip and this is strip and this is strip. There are 3 strips in this. This is 1, 2, and 3. No square and no rectangle. I mean to say, and I think rectangle is like this, it's different type of rectangle. You have to take into consider this is a rectangle and this is trapezium and this is trapezium. No circle, nothing in there. So 1, 2, and 3 areas where dimension here 70 and dimension here something, 65 something, and like this. These two, all dimensions are this. You can use them as trapeziums as well as rectangle. That's no problem at all, right? So we go back and see how it works. You can see that one, And I say trapezium, area 1, area 2, area 3. So there are 3 area 1, area 2, area 3. And we say there is, that is 7A is this, this is area 7A plus 8A, and that's 2 sides of the trapezium with A width. So we got this formula 7A plus 8A over 2 into A, and then we go to area 2, which is another trapezium, that is 9.31A, 9.314A plus 11.314A, sum of these two over 2 into A. And area 3 is a rectangle here, so 8A into A. So we can say here, first one, cell, this 7A plus 8A, we got this, and here is, you can say, over 2 into this, we got this area. Other one is 8A into A, no, it's a follow. So sorry, this is this one, and that is this one, and you can say it is here first one 7A plus 8, 7A plus 8A over 2 into B881, and then it is 9.314A plus 11.314A over 2 into this A, and then we can say rectangle 8A into A, and total is all these 3, and we got this sum. Then perimeter is also same. We can say we go start here. 8A we are starting here. Let's say 8A, A, 7A, 9A, 9.899A, A, 8A, A, 6.5 something, and 9 point something, and 1.41. So we got all here. We can see here now in cell 8, A, 7, 9 point something. I'm just speaking short. You can assume A is there. A, 8A, A, 6.5 something A, and then 9 point something A, then A, and then 1.4. So, okay, fine. So we can say this is done. So now take extrusion here, and this figure planar AD is square rectangular. This is area F here F, and this is here H. So we got this answer here, and you can say same way. You can say this twice F is the multiplied and plus G to H. G is parameter and H is height. So N is resolved. O. O, very simple, means there's no complication in that. You can see, like I think the different direction better. There's enough space above, so no problem. We can say here, you can say 8A, 5A, and two semicircles with two rectangles. And this is radius 25, radius 20, and radius 15. 50 is internal, 20 is middle one, and 25 is external one. So this is very simple. Area 1, area 2, area 3, area 4. 1 is rectangular, 3 is rectangular, 2 is semicircle, and 4 is semicircle. Easy one, so we go back and we see how it works. Oh, I think I'm lucky I'm going one by one. Easily, there's no problem at all, but calculation is a problem here. Area 1, rectangle, it's 3A into A, so it is 3A into A. Then area 2, semicircle, half pi r square minus half pi r square. So it is, we are taking in different tone, we are taking difference of semicircular area. So no problem at all. Half pi r square minus another half pi r square. One is r 2.5a and one is 1.5a. So half pi r square here, 2.5 this, and minus half pi r square, and that's this. So it's same, as we got last time. 628 we got somewhere, I remember. Let me see what it was. Just for reference. Yeah, it's we use same method, and also we use same method somewhere else also. Here this was just different method, but area result is same. It was just different. As I took central axis, and we got the same value. There's no difference. Is validated well. So we can say N is here, O is here. I'm sorry. This O, we got this semicircular area, difference of 2, and we then go to rectangular area, that's area 3 and the 3 into A, and 4 is same again, that's as I said, this here, this I said here and here. So we got total area of this 1 and 3. 1 is rectangular, 3 is rectangular, and these are semicircular, 3, 2 and 4 will be separate. So 1 and 3 is here, and rectangular areas are here. So 1 is here, that is D and F, and this is here, that is E, that is you can say B and B. I'm sorry. Rectangular area is 3A plus 3A. So we calculated here 3A, right? Okay. That is the other one. So here is that, this is here C plus E, and this is D plus F. So we got this rectangular internal area is, this perimeter now, this area. So perimeter talking 3A. This internal and external also both are same, but are showing separate 3A plus A, 3A plus A. These are two same. So total perimeter external internal is sum of these two. Now move on to further, then we can say semicircular internal and semicircular external. Semicircular internal is pi r, that's in meters, pi r on 5, and the other one is 2.5. So you can say pi r this, that's the other one is this. Total circumferences, you can say one sum of these two, and we got this. So you can say now different volume of plane figure, value of circular figure, value of surface of plane figure, and surface of figure. We can say here total area is, in this case, what's the area? Go back to area. Say which grid is that? This area is rectangular areas, and that is G. So G or O are here, and O is this here, and other one is semicircular area. This here total area is H, and H and O. So it's okay. 2 and here, so you can say 2 into G. That's okay, fine. Then parameter, that is I. There's J. I'm sorry. This is parameter into this. So this is 2J. That is parameter into D, and parameter here is yes, this is total parameter. K. So K is okay, fine. It's here. It's semicircular H is here, and then N here, which is circumference total in and out, external internal, That's N, and we got O that's here. So we got this. Okay, fine. This is validated now. Both are there. So we have done. We have done with O. O is done. So I just put this in a different tone. Just why enlarge this to is okay. This is fine. Now we go to P again. We go to P, which is also here. Let us see how it works. Let us see. P, real shape P. Real shape P, and you can say you can't do without something. Let us understand what is P. This is P. You may take it different way, but no problem. It's very clear here. 1, 8A, 5A, these three areas, 1, 2, and 4 here up to, and then semicircle of radius 25 external, 15 internal, and 20. So 25 is here and 25 is here. In fact, this is division 25 and 25, and this is also 25 in that case. I mean, this 50 is this, so this is 30, and this is 8A and 5A. So it's easy, means nothing very important in this. You can see now go and see how it works. A P real shape. Area 1, area 2, area 3, area 4. 4 areas are here. You can see these areas again. 1, 2, 3, and 4. No fifth area. So area 1 is rectangle 8A into A, and this is 8A into A. Area 2 is rectangle is 1.5A into A, and this 1.5A into A. Area 3 is semicircle, and that is semicircle, I mean to say, just you got semicircle, and that is half pi r square, and then minus half pi r square. So we are taking again r is 2.11, so this is same formula, half pi r square minus half pi r square. So we get this answer. Area 4 is rectangle, and which is also, you can say, rectangle, and this 1.5 into A. Then total area is 1 plus 2 plus 4 is for rectangular, 1 plus 2 C, D and F, C, D and F, and this semicircular is only 1, and that is this one E. So we got two areas. We can sum up there here G, H for reference only. Now we go parameter, that's 1.5A, 3A, 1.5A, rectangular 1. And rectangular is internal, you can see here. Rectangular internal is here. Because you cannot take circumferences, so this and this and this, and this and this and this, like this up to here. We can take this 2A, 2.5A, 8A, A is 3A, 2.5A. It's all 1, 2, 3, 4, 5, and this is 1, 2, 3 here. That's how it works. So variable 1, 2, 3, rectangle internal, 1.5, 3, 1.5, external 2.58, A, 1, 2, 3, 4, 5 are there. Then total parameter internal external, we can see this 1.53, 1.5, and here 2.58, 1, 3, and then 1.5. We got this value. Two are added up here. We got this, here is sum of these two. This is sum of these two. We got sum of parameter here. And semicircle, one semicircle 1.5 r, which is pi r, 1.5 r. Semicircle external 2.5 r, so external. And we can say total circumference is sum of this and 2 is m and n. We got this. So it's easy. Volume, direct volume is rectangular volume, and that is this area, rectangular semicircle here. Rectangular circle, this is I is the column G, says G, where is G? Yes, rectangular areas A1 plus 2 plus 4, and this is P is here, extrusion, and then semicircular area, that is here, semicircular area, is here, H, and this is H, and this is P. That's justified, so you can say now surface area, that's twice area means what was there is G, so it is there G, and L, LP, and L is here. L is this parameter, this A, right, and if you see this one, here you see H, and H is here, and you can say O and P, where O is this total circumference O, and P is same. So we got this answer, and our P is resolved. So we go to Q. P and Q. I don't know how many I'll be able to do it today. No problem. So 1.5 hours only gone. We can wait. So it's something, indifferent, you can say. It's, I think, what's time now? 7:30. Mm, it's 7:30. Okay, no problem. That is for half an hour more better. Sometimes actually I'm not able to sit longer. That's the problem. Q. What's Q? The Q is little different. It's very, very complicated. In fact, let us see what is Q. We have to be very patient to understand Q. It's a little different in this case, and it's Q. You can say here also I put down before, so you see how Q is. It's like this, and I put the tail, and you can say 5A and 8A here. And there are two semicircles with two rectangles and this trapezium. I put an angle here, and this is 45, this 45 angle here, and here is trapezium. So we have different shape. So 1, 2, 3, 4. 1 into rectangle, 2 and 4 semicircles. One, two, three, four, and this is here. So let's do it now. I have seen this clearly. Two semicircles and one trapezium here. Rectangles, semicircles, and trapezium. Angle 45 here. Let's do it now. Okay. So area 1 is rectangle. That is area 1 is rectangle, and that is like 3A into A, and there's this one 3A into A, and go to area 2 semicircle, the square, semicircle, and it is half into pi r square minus again half pi r square, and this is 2.5, and you see half pi r square minus half pi r square means you cut two semicircles and then deduct one from other one, so you get same answer as you take up. Now say a 3 rectangle, 3 into 8 is same as this one. Area 4, you can say area 3 same as area 1, so I say area 3 equal area 1, area 1. So it works like that, right? Okay. Then we can say area 4, that is semicircular, and let's see, comma is a problem here. Yeah. Okay. So area 4 I say is D, and it is the same as area 2. I say equal area 2, and so we say start area 2, we link it here. Now area 5 trapezium, that's different one. 2A plus 3, that is 2A plus 3A, you can see 2A plus 3A there. Here these dimensions 1 and other one 3 and 2A, and then this one is that one. So we go back and say 2A plus 3 over 2 into A, and this is 2A plus 3 over 2 into A. We resolved here 5, which is very complicated, but we did it better in a way by putting angle 45. So now total areas here are rectangular areas 1, 3, 5, 1, 3, 5. The rectangular areas, and that is what is this. The 5 is C, E, and G. We got this. Then semicircular areas 2 plus 4, 2 plus 4. So we said 2 plus 4, that is, this is you can say D here and F here. We got this. Then total areas of both is no problem. You can say H and I, but that's not required. What's required is different one. What's required is something else. Say, no, you see, we have gone through areas now. Now, there's one more thing in this, I think we have to consider area 5. Area 5, really the triangle angle is shown. What's that? Let us see. That's very complicated one, as I said. Area 5 really the triangle. Let us see what's that triangle. or say triangle, which we have to consider very, very clearly, You see, area 5 related triangle. Let me see the diagram first. Is Q available? Let me see if he first. Q available. Oh, come on, yaar. Come on, yaar. Yes. Q, where is Q? Let me see. Drawing of Q. Is Y. Q is gone. I'm not able to find which drawing is that. No problem. Let me see. Is there? No. I got it. 5, I got it. Okay, got it. You see, it's pan, it's Q. All right. So, what actually is there in this figure? 5 area, there's a triangle. This triangle is a part of this trapezium, and is with this vertical of Q making angle 45. So we have used 20 and 30 for that area. But now point is, we have taken, as far as perimeter is concerned, when we calculate perimeter for Q, external one, in that case we have to deduct this portion hypotenuse of triangle from that dimension. So I give you now what I did. Let us see what I'm telling is. This triangle is there, this triangle. This Q and this tail, here is this triangle here. It's not going to affect area, but perimeter is going to affect, because its hypotenuse is lying on external side of Q, and this is external side. We cannot take whole external side, we have to deduct this one from here. That's what it says. So it's an interesting one. And it is, we can say here, you can see that. What we say, let us just come and sit down here and see of this. Total parameter we have done, that's okay. We have taken total parameter. That's, we are talking of, area of triangle, this here. It was a triangle related, this is area 5 related triangle, angle as shown, and triangle, angle is shown there, so it is shown, those triangle, angle is written, I don't know for what, let me say triangle, angle, okay, leave this. Now triangle in area 5, sine 45 I'm taking, sine 45 is here, sine 45 value, sine K 3645 is there, this degree shown here as pi 180, pi of 180, right, this is. So parameter external side, that is 1a cosec 45, right? 1a cosec 45, and this is 45 cosec, because there are sines, we get cosec 45. That is what I say, because of 1a we are using this hypotenuse, and we got this hypotenuse 1 as 14.14. So it's a rectangle parameter is 3 plus 3a, internal rectangular parameters 3a plus a. Let's see that one. 3a plus 3a. Internal is these two. That's okay. 3a plus a. That is 3a plus 3a. Then rectangular external is 3a plus 3a minus triangular hypotenuse. That's where it is. This one and this one, but deduct this one. Triangular hypotenuse. That's what it says, So it is triangular hypotenuse that you deduct from this. So this is 3a plus 3a minus M836, and M836 is this one. Correct, yes, M836 is this one. So what do you say? That 3a plus 3a minus M836. This is 14.14, but this is dimension there, 14.14, 1 cosec 45. But we have to take into consideration value of a, I think. Triangular hypotenuse rectangular, external 3a plus 3a. In terms of that, that's okay. 30 plus 30, you can say. and then minus triangular hypotenuse, that should also be in terms of A. So it's 1 for 1, we say if I did it directly, actually it should not be like this. It should be 1.414A. So let us say 1.41, 1.4, sorry, 414 into A. It should be in terms of A, and that's B836. That's right one. So I converted that to this one. So okay, means same thing is coming. Let us see it's coming same or no. Let us see it's coming same this way and that way. It doesn't matter. So we converted that one that missed before. So I converted that one now. So B, this is 3B plus 3B minus 1, 4, 1, 4, 3. So that total parameter, the internal, external, this one, this is internal, this external, so this is circumference now. Circumference. What is circumference here? बना क्या कर रही है? Circumference, so semicircular internal is semicircular internal. Disturbance is there. Sorry, disturbance is there. I'm sitting in my home, so there's disturbance. Sorry. And now circum is in meters, and when I say m is meters, so don't confuse about that. Pi r. R is 1.5 plus, you can say pi r, and r I can take like this. You can say down, so this is clear. Pi. This is pi r, and r is 2.5 a actually, and 2.5 a is not r. Just be clear about that. And oh sorry, other one it is not this one. By r, and r is 2.5 a, and this is other one is also 2.5 a. 2.5 a. So it's by r. So that's what correction is required from time to time. Means one go is not enough, but I can't check my own work. So this is, I can say pi r 2.5 a plus pi 2.5 a. So we got this answer, semicircular. Now external and total circumference. Internal we have here, and external we have here. So total is this plus this. So we got this value to r. So again, extrusion is there, volume, this is h. We have h here as we said. H was here, that's okay. Rectangular h is there. And we have t is here, that's okay. Then we can say h is there, and in this case we have I. Where is I? We can say I is perimeter or not. I mean to say I is, yes, semicircular area this is. That's okay, I. So semicircular is this, I. So we say I here, and T. So this is volume of semicircle, and area, this area was H. So this is H plus P into T, H and P into T. P is perimeter and T is here. So this is okay, and also here this is 2I836. I is S is here, I is okay. 2I is S and T, S is circumference and T is extrusion. So we have done this. It's done correctly. This is Q is done. So I put back Q. I put back in its position so that you should not get confused with that one. This Q comes back to its position. Now R. R, we have to R, now we have S, we have not U, we have so many R, S, U, then we have W, then we have X, and we have many more. So let us see if I can do R or not, because I have been asked that we have to do something, and it's too late for me now. 1:45, 20 minutes, no problem. Already nearing 2 hours. This is R, and we have to see R here. This is your R, beautiful R, very complicated one. You can see this one. You will see how it is going to be. Maybe you are confusing what is this. Yes, you must be confusing about what is this. I'll show you what is this. This is R strip and this is R strip. 1, 2, semicircle, 4 and this. And if you see just more below up, you'll find a curve here, right? Semicircular curve, and this is strip here. So this you can say, this cannot be considered a trapezium, right? You cannot consider it as a trapezium. If you go to R, QR, I think I see drawing now. It is, it is. I divided this into this portion into, you can say, five divisions. You got my point. These lines which you're finding, these are for, various, is of dimension 1, this dimension 2, 3, 4, 5, so 5 divisions I did for this 10 meters. So that's what I did there. you know this is okay, rectangular strip, and this is also rectangular portion. This is semicircular, this is rectangular. So I did this one. This is special, means here are 10, A here. So because of this trapezium, curved portion, I can't take trapezium here. So what I did, I divided this 10 meter width or A into A or 5, A or 5, A or 5, A or 5, 5 divisions, and then I'm taking similar each trapezium here, because when I say 2 meter division is there, this curve is actually approximately same as I'm saying 2 meters. I try to superimpose those lines of this. I try to superimpose the same thing. There's no difference. So there are 5 trapeziums here, 5 very A over 2 depth trapeziums, because these dimensions are measured. This is A, so A over 2, A over 2, A over 2, A over 2, and A over 2, 5 A over 2s. So that is same as A, and I take 20%, you can say, of A value in this each trapezium. So we have 5 trapeziums here. That is only specialty in this. So rectangular area 1, rectangular area 2, rectangular area 4, semicircular area 3, and this area 6, which is deviated into 5 areas. So got my point? I think you got my point. Because after all, circular are composed of not actual circles, but something else. So now that's area 1, area 2, area 3, area 4, area 5, area 6. Area 1 is similar, means it's nothing complicated. It's A into A, so it's A into A here, no problem. Area 2 is a rectangle as well, 1.5 into A, so that's also not a problem. So we can say 1.5 into A. Area 3 is semicircular one, that is not a problem as well, because we can say half pi r square minus half pi square r, again we can say 2.5, but I use same formula. You can see result as well, half pi r square 2.5 this one, and half pi r square 1.5 this one. That's okay. Area 5 is rectangular as well, so it is, you can say, area 5 is rectangular as well, so 1.5 A into A. So this area 4, you can say area 4 and area 2, I think, are same, because I have taken this area 4 is equal to area 2, you can say area 2, area 2, so that's not a problem. So you can say area 2 here, and we just link that one, and you can say this is another one, area 5 trapezium. I taken 5 numbers. Trapezium, you can say 5 number trapeziums. Trapeziums, the sum of all trapeziums here. That's a little difficult here. You can see how these are 5, 5 trapeziums here. We are taking, I didn't write this formula there because already it's in this is 2.9, all the same dimensions here, 2.946 A, and then 3.01 this value divided by 2, so this is one trapezium. Then because 2 meter is there, so I can say, you can say 2 meters, or you can say A, you can say 0.2A, it's same thing, but because it's a trapezium, I am using directly between the 2, and 1 over 5th B A, 1 over A or 5th, you can say 1 over 5, so 20% of that. This is one part of trapezium. Then this same 3.01 starts again, and then 3.091 next one, and same thing here, same, and then again 3.091 starts here, and 3.191, and it applies here. Then again, so 3.191 comes here and goes there like this, and then it goes to 3.391 again, and you can say in next one here 3.1 we got this. So these are 5 trapeziums, many trapeziums with your 5th dimension, so that we don't worry about arc, and trapezium arc is converted to trapezium dimension, so it's done that way, and I think it's okay. Area 6 is a triangle, and that triangle area 6, and that is, area 6 is a triangle, and that is, what you can say, this triangle at corner, actually this area 5 which I told you, not 6, area 5, the 6 is a triangle, and the dimensions are there given 6.54 into 10, 7.775. So this triangle 6 half into 0.775a into 0.654a, 0.654a and 0.775. So that's what is this. So we can say here half into base into height, half into base into height. So we got 6 areas calculated. Total area is number 1 is rectangular, that's number 1. Area number 1 plus area number 2 plus area number 4 plus area number 6. So 1, 2, 4, 5, 6. 5 is also there, I'm sorry. It's a trapezium now, so we are taking it in trapezium, rectangular. So area 1, 2, 4, 5, 6, and this is 1. C is 1. D is again rectangle. E is of course 3, and E is 3, but there's no E, 3 is not there, so 4. All F is actually not E, F is there, G is there, and H is there. Only the semicircle, which is E, will sit separately, and that's here, see, that is, I'm sorry, here, C, E, so this is all 4 areas, 5 areas, and this is semicircular areas. So total of these 2 is this, so that's not very important, but we have taken that one. So now we see parameter. Parameter, how parameter of this case is, 1.5a, 3a, and 1.5a, and then this is internal, and this external is different. External is different actually. External is 2.5a, 8a, a. You can see this diagram. You can convince yourself. Maybe I'm wrong, but here nothing is wrong. This is, you can say, 1.5. You can say internal is 1.5a. That's this one, and 3a and 1.5a. That's internal, and external is 2.5a, 8a, a, then 3a, another 5a, and then 3.449 measured here, and then a, and then 0.75 measured here, and then 0.6 measured here, and then 5 this is measured here, and then this is 2.94. That's okay. It's up to here, and you can say that these dimensions you can check yourself, and you can see as 1.5a, 3a, and 1.5a, and here's 2.58 a, 3, 1.5, 3.449, 0.775, 0.654, and 2.946. You got this value. Same way, total parameter, internal per external. This is one parameter. This other parameter. You can say this is internal, this is external. So this is LM. We got this in semicircle area is here. Pi r 1.5r. This is, and you can say this is internal, this is external. So both are here. Pi 1 pi r, and this is also pi r. So this is also pi r 2.5, and this is 1.5. So sum up of these two. That semicircular area is how much? External semicircular length minus angle 24, because this angle is different. 24 over 80. We have seen that one here. This is this semicircle, because this from this semicircle this distance has to go. So you measure angle of this distance. You got it? It means this is semicircle. This portion occupied by your area 5 has to go from perimeter circumference. That's what we did, minus, and this angle is measured on AutoCAD. It is, that is, whatever angle is that, we have to be careful about this. This is 24 degrees, and this 24 degrees that we have to deduct from that. This is here. So why say net semicircular external length minus angle 24 over 180, because we are taking semicircle is 180. So into semicircular arc length, that's here what we say P 842, P is this is semicircular external, minus 24 into 24 over 180 into P842, P842. So we got this answer here. That's arc length deduction from semicircle. This is going to be deducted. This is what it means is, this is angle deduction, and we can see then this is net one, this is deduction. This is total circumferences, internal plus external. This is here internal. This is sum O. This is O, and then Q. This is Q. That is, you can say this is deducted from maybe hold on. This is deduction from external one. So internal external, this is the sum O, and external is Q. Net is this one. This deducted minus this. So P842 from this we deducted this. We got value, so we can sum up these two and we get this value. So now volume, that is in rectangular case, I, and let us see where is I. It should be right first of all. I is, yes, it is okay. I is there, and then you can see S is there, of course, and then we can semicircular is here. Semicircular area, that is J. So this is J, and S of course is there. So we have areas of correction. Now it is here, and we can say two end areas. This is same as this I. This should be I. So this is okay. N and S, N and S. S, and this is N, which is circumference, maybe perimeter actually, and this is perimeter. And here is two end areas again. That's from this is I J, this J, and R S, and R S is here, S is same thing as here, and R is this circumference. So that's okay. Interbraxional. So this right J J. Hold on. This is J. This is I for rectangular. So this is I for rectangular, and this is J for J for semicircle. Let us be sure about J for semicircle. Sure. J, yes, that's okay. J for semicircle, and then it should be also here J. So this is J, yes, okay. It's okay, fine. R and S, and R is here and S. Total circumference R and S. So this is what we do. We are gone. S is over. S is now done. And now I think before 2 hours are complete, I'll just show you sketch of R. Sketch of R I'll show you so that you can R again I show you this sketch because it's important sketch. It's not that easy as it thought. It's really important one. You can see this again. This arc we deducted from that circumference, and we use this 5-1. It's very important case. We cannot take it for granted. It's not grantable, and we now go to S. S is here. S means is something not extraordinary, but you understand what it is. That's important is, It's so simple, you can say, so simple it is. So simple means we just took a rectangle here and rectangle here, a semicircle here and semicircle here. It's like driving car, You come here, you go back and you go back and put in here. It's S curve actually, though it's reversed in that, but it's like this. So we have the radius here, so 12.5, 30.17, this 27 here, and this is 22.5%, 5 is 50, 50 by 8 and 5. So you can see that. Here's the area 2, 3, our curves, semicircle curve. This is, 4, and this is 1 here. This is what is so simple, and you just see sketch 1 here. Saskatchewan is there, and then S is here. Yeah, my friends, already 2 hours over. I'd like to take the next time because it's already, I think, 8 hours time. I would like to say something because it's end of year. It's end of year today, 31st December 2020. Just for your information, 21 is started from tomorrow. You know it very well. So it will give another boost to us because 21 is something else. Means entry is coming in along with material. 21. So I wish you all best for next year for 2021. Though it's not going to be very comfortable year because of this COVID-19 strain and strain as well as what do you call it, variant, both coming in very fast, rapidly. So this year is gone. Only 4 hours left to go for this year to go. I actually wanted to give you certain gift, and this is gift I gave you yesterday and today, and I'll continue tomorrow also. Possible because this I have to finish this. This is S, then I have to take U, and because S T is not required, just U, then we have to take W, VW, and X as X, maybe X as well, and the Y, and also 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So tomorrow we have these 10 letters 1, 2, 3, 4, 5, 6, 7, 9, 0, and we have S, U, W, X, Y. So 5 these and 10 those. 15 letters we have for tomorrow. I think it shall also be difficult to come up with this. And अरे पैर में नीचे हुआ है
कैसे हो मामा जी?
बस ठीक हूँ ठीक ही हूँ ठीक है
ठीक हो?
हाँ ठीक हूँ, कोई दिक्कत नहीं है भाई। अब थकावट बहुत होती रहती है, वो चलते रहते हैं थोड़ी बहुत, क्या करें।
अच्छा,
हाँ वो है वो यश। शादी फंस जाएगा करके सारा हो जाए, फंस जाएगा एक बार कर ली तो So, gentlemen, thank you very much. I